So you said on Twitter, there aren't any breakout products yet in crypto that depend on low cost, fast networks. That's just it. If you don't believe it will ever happen, ETH L1 is all you need. If you believe it will, L2s aren't going to work. What do you mean by this? Why won't they work?
Well, because they fragment the capacity, they fragment the user base. So like the UX becomes very, very complicated. And you kind of, I don't know if you ever worked at a big Web2 company, like Dropbox, we had one giant MySQL database for all the folders, because as soon as you start fragmenting them, links become very hard to create links between like different users of different folders, and tracking consistency between those, between two different databases, is a major pain in the ass. You would have to synchronize everything through the L1. And that just happens at a large enough scale that that fragmentation creates like massive composability, like either UX problems because you're like, oh, you're not in this rollup, go to another rollup kind of thing, or like you have to go resync through the L1, and it's going to create the same kind of costs. And that's very, very difficult to deal with. And you can think of it as like NFTs are like a perfect example of this. You can't have an NFT in every rollup. It actually can only be bridged to one. Tokens, you can kind of fudge with this and create different markets. But if I want a specific NFT, the marketplace that it's sold is the marketplace that I need to buy in. And it can only exist in one of those. And then therefore you've kind of broken up composability of like just the marketplaces for that one single NFT by creating these different states. So that's, I think, kind of the fundamental challenge with L2s, is their trade-off in like this. You get performance benefit because you create this single global lock around a state, and then you can go work on it asynchronously from everything else. But you're creating kind of a very hard composability challenge.
Anatoly, you had a tweet also talking about like the hypothetical example of an L2 building on Solana. Now you said that wouldn't actually affect the fees because it's not that you're competing for bandwidth or compute. It's actually the state contention. So could you maybe talk about that and say how isolated fee markets play into it?
This obviously, there's limits to this. If Solana is over capacity, fees will go up. But that means that it's really bandwidth saturated, and then the dollars per byte that you're submitting to the chain are now going up. There could be other ways that it's saturated through compute and other things, but those actually do tie into state contention, I think, a lot closer. So assuming that Solana itself is not saturated, what an L2 does is that you can think of it as a bridge into something that asynchronously processes some state. And the way that bridge works is that it runs a bunch of orders, transactions, and then submits those transactions to the L1. And that submission part, you can think of it as settlement, that can occur in batches asynchronously, kind of like at whatever the cheapest opportunity time is. And the computation part is occurring locally in that system. And what's going to create fees in that state is if you have, 1,000 people that all want the same NFT, or 1,000 people that all want to take the same liquidation or trade. They will bid up to access that one economic opportunity up to the cost of that opportunity, right? So if I'm going to make $100 in this liquidation, I'm going to bid $99 to go be first, because at least I'll make $1. That obviously doesn't always perfectly work out like that, but you can kind of think of it at the most perfect, efficient market. Somebody will always bid up to that to be first, to like take the smallest amount of profit. So those fees are spiking, not because anything's saturated. It's just simply because there's economic access to state. And that state, you cannot partition that. Like if you only have one liquidation that's on sale, you cannot put it into two different rollups and then have half as many fees. It's simply because there's this one liquidation. It's kind of like an NFT, right? It's unique, and it's a unique opportunity. And it doesn't matter if it occurs on the Solana L1 or in a rollup. So this obviously breaks down as if Solana itself is saturated. Like there's so many like economic opportunities happening on Solana that all at the same time that you cannot fit them all into the block. And now they're fighting each other to be first. And at that point, what the validator should do is they should double the cores in the network. We should all I will personally fly out to the to 400 data centers or however many. Mert will do it. Like everyone will do it, and like go double your cores. Like the network is saturated. Like that at that point, like this is kind of I think the philosophical difference between Ethereum and Solana is that we're like, okay, we're saturated, just double the cores, and we're good to go. And then prices then go back to what they should be based on the economic opportunity.
Hey everyone, quick break to tell you about Jito. Jito is the #1 liquid staking provider in Solana. Jito's been known for their MEV software, and now they're the fastest growing liquid staking provider in the Solana ecosystem. Solana DeFi summer is heating up, and what asset do you want to use in DeFi? Liquid staking tokens. Why? Because with Jito, you can take your SOL, stake it, and get instant access to liquidity through their liquid staking token, Jito SOL. You can then use Jito SOL throughout the Solana DeFi ecosystem while earning yields through MEV rewards and staking rewards with Jito. And Jito makes staking super simple. You can take your SOL, stake it, get instant liquidity, and start earning rewards all within 3 clicks. And not only do they make it simple, they make it secure. Jito has 7 audits, they have more than 1 million SOL staked, and they're one of the most respected teams in all of DeFi. Jito is for whales who need deep liquidity. It's also for people like me and you who just want to get started with liquid staking. You have your SOL, why not stake it, earn some yield, and start dabbling in Solana DeFi. So go get started today. Check them out at jito.network/staking. That's jito.network/staking. I'll put a link in the show notes. Use the link so they know that I sent you, and go get started today.
So one thing I want to touch on here, just to make sure we do the L2 folks justice here. You said that the reason why L2s wouldn't work is because of fragmentation, and probably talking about complexity as a developer as well. Well, so 2 things to that. One is that, so are you saying like, are you like bearish that people can come up with abstractions to remedy that? And 2, more importantly, some would argue that you actually only need 1 L2, and then you don't need all these L2s.
Yeah.
What do you say to that?
So then that system where you have like basically you take SVM that runs as many things in parallel as it can, like up to the limit of the, it always increases hardware capacity to meet the demand. And then you take all that data and you dump it into dank sharding, like perfect implementation of a DA layer that tries to maximize its DA system. So you have 1 L2, 1 bandwidth optimized system. That's basically what Solana is. Like there's some implementation differences there, like which I think we're all kind of slowly working on. They're just not like a major fire, but like Solana itself can asynchronously execute all the programs and then pick forks separately in a separate pipeline than execution of the programs. So that kind of gives you that like data's really quickly confirmed, all the forks are quickly picked, but then these bigger systems can go execute on the programs. You can then do like batch ZK verification if that's what you need. Like all that stuff is all doable on Solana. This is effectively like that single L2 that can dominate and take up all 100% of the DA bandwidth. That design, you have 1 L2 that's able to take 100% of the DA bandwidth. That L2 needs to implement localized fee markets, because if a single use case can saturate the fees for everyone, there's a need for 2 L2s, right? That breaks down. So then you're broken composability. So it's got to implement exactly the same system as Solana does. That's great. Like, I mean, this is where, like, if you look at like the conversations me and like colluding Node have, we end up, okay, yeah, everyone's working towards the same goal. Like,
Yeah.
but I think there's still kind of like a fundamental difference between Solana and something like that. I think like there's not going to be a demand for Solana to do dank sharding, because that really breaks that idea of information synchrony across the world. This is like the one aspect that Solana was started with, and I think is building towards, that I think is really important for a permissionless some blockchain to implement. And I think since we're the ones doing it, we should keep doing it. Like, I don't want to split the data availability, even though you might be able to get an improvement in bandwidth there. It's actually does still have a trade-off. You still need a system that is working for that use case, that when I submit 1 bit, like here, that it's equally observed in like Singapore, in Brazil, everywhere in the world, as fast as physics allow. Because that actually creates value for the world. That reduces the information asymmetry between any two players. It allows for fair markets to exist. I think that's the one core use case that you really can't optimize away with like all these other systems. L2 itself could actually implement that. This is kind of like the L2 that's running on this one DA layer could be implement that like perfect synchrony, but it's effectively Solana. It's running the same as fast as possible consensus, and then it's dumping its data to Ethereum because it's wants that data availability bridge. So like, sure.
So you're basically saying, like, if I understand correctly, because I might be a little slow today. So you're saying that, well, L2s or the ETH and modularity roadmap and Solana actually have the same end game, and they would basically have to do what Solana is doing today to scale anyways. Solana just does it in an integrated way, and they don't want to compromise on the information sync being synchronous around the globe at near the speed of light, whereas Ethereum will have to compromise on that unless they add the sharding layer to the L2 itself.
The data availability roadmap for Ethereum, the way I understand it, is like the end state is like these dink sharding subcommittees that can all sample each other. They will be able to increase the bandwidth because part of the one subcommittee is getting different blocks than another one. So that implies that you don't have a single state that with perfect synchrony, right? Like you effectively are splitting the system. So it's just that you cannot take that optimization without this sacrifice, right? And if that sacrifice is really important to you, then you would design something like Solana where everything is built around how do we propagate the data as fast as possible to as many nodes as possible. And Turbine and all these things are the solutions to that. So I think the idea of having like a single rollup that can take up all of the bandwidth of this data availability layer, whether it's Solana or Celestia or Ethereum, I think that idea it's like something that I think a lot of the engineers agree is probably the more efficient design. Like if you have a single rollup that can take up all the data availability bandwidth, you eliminate all of these like composition bottlenecks and all this other stuff. But that's very hard, like I think, politically to swallow, because what are you going to do? Like say like Arbitrum is a rollup or Optimism. Like the way that free markets work is the faster, like we get faster development when there are free markets and there's competition, and we don't have the single enshrined thing. So it's good for Ethereum to actually not enshrine anything, at least for like probably this decade.
What is the key trade-off that Solana is making?
Hardware is more expensive. So if you need more bandwidth, you got to increase the hardware. If you need more bandwidth in Ethereum, you have more subcommittees. And the subcommittee hardware is fixed, but that means that each subcommittee is not observing the state at the same time. Like that's like you cannot solve both of those problems at the same time. There's a fundamental trade-off there. If you care about like having state everywhere equally, then you need more hardware.
Yeah, and it sounds like that's going to happen no matter what, though. Like if you think about Vitalik's post that he had, it's like block production is going to use more hardware. It's going to be more expensive. It's like Solana is just having a path-dependent way where they're embracing it from day one instead of working back to it, what you see in Ethereum. I think like one good thing about L2s is it allows for a lot of experimentation, but that's something that you could see with the SVM and L2s as well. So like, is that like, if you're thinking about the SVM and how that benefits Solana, is that kind of the key thing? Is you might see experiments there that you can adopt, or is it just building out the tooling or something else?
I think there's if you're talking about the application space itself, that's kind of just a never-ending problem, because like every 2 years, like developers are expected to learn a new stack. It's just kind of been part of my career. Like you should, and this is where a lot of the work that we did in SVM to use LLVM and these other components is like to allow that kind of experimentation that we can take Move or Solidity and start building tooling to integrate better with it. But it takes work. Somebody has to drive it and push it and like do the iteration. It's not always clear that there's even demand for that, because like a big part of me thinks that like smart contracts are actually not a language that is like a distribution language. It's not like Swift for iOS where you get access to their distribution network, right? Or JavaScript for the web. It's a backend system that's kind of more like building on top of Postgres or MySQL or whatever. And do you really care? Like, do you need that many languages for that, or like that many solutions? Like, you kind of end up with like, this is like the 1-2 engineers that write kernel code, your driver code. And once your drivers are built, you have all the other people on top that are building all the applications and everything else. But like, once those drivers are built, I don't know how much innovation there is, or like, it doesn't seem as big of a surface area for innovation as the application layer itself.